Hello and welcome to our presentation. Today we'll be talking about flying cars and with a main focus in the safety features. I'm Luiz. I'm the team leader for safety of flying cars. In my free time, I enjoy learning about cars, computers. Um, in the future, I'm planning on going into computer science and biology.
Hello, my name is Jason Diaz-Avido. I hope to pursue a career in the aerospace industry in the future. My highest goal is to be a commercial airline pilot.
Hello, my name is Gabriel Rios, and I'm interested in the creation of flying cars and how they could be possible by the year 2050. I also wish to pursue the career of being an aerospace engineer.
So the safety of flying cars is nowhere near where it has to be in order to be implemented for daily use. So our goal is to create systems that make the flying car as safe as possible for to be flown around other flying cars and that are able to handle emergency situations efficiently and effectively. We're also working on making sure that the pilot and driver is very prepared and knows what to do in any situation. Here's a quote from Elon Musk where he talks about flying cars and how one of the main challenges is making one that is super safe. Table of contents. We're going to go over 3 topics today, and the first one is the AI air traffic control, along with the exterior airbags. Second, we're going to look at a protective chassis design, and third, we'll look at the flight school and bird strike prevention. Here are the group roles. I have been working on the artificial intelligence and the airbag safety systems. Jason has been working on the exterior protection, and he has been the safety specialist. Gabriel has been in charge of the AI as well, and working with the license registration. First off, we're going to talk about traffic control and airbags. So for ground cars, we have stoplights for traffic control, and we have regular airbags for protection. So how would this look like on flying cars? My 2 ideas are AI air traffic control and exterior airbags. Through various machine learning algorithms, we can control traffic just as we do with the stoplights, and with 3D sensor coverage, 360 sensor coverage, using different types of mapping technologies, we can use airbags to prevent any damage to the chassis and prevent any falling debris. The details on the AI air traffic control. Uh, it is very essential that all flying vehicles have traffic control, and at the moment, most, if not all, flying vehicles need to have traffic control. Flying cars will make it so that there are way more objects up in the sky, and humans simply won't be able to keep up with that. So the only way to fix this problem is to automate it through computers. This will also make everything way more efficient. The concept of a computer that can control countless air vehicles is bound to happen simply because eventually there will be too many flying vehicles for humans to handle. It is important that the driver and pilot receive very accurate and instant information. So humans, it would be too dangerous to have them control everything and possibly make accidents. So the only way we can fix this is air traffic control AI. Here I have made a UI. Is basically an example of what it would look like for the driver. On the left, we have a little text box or message receiver. This is where you will receive instructions from the computer, and then you can fix whatever you have to do to get to your location on time. On the right, we have a map, and it's gonna display any restricted areas. Next, we have the same design, but this is what it would look like under emergency circumstances if anything were to happen. So the engineering behind it. When talking about automation with computers, we're almost always talking about artificial intelligence. There are multiple branches of it, but we're mainly working with machine learning and deep learning, and we're working with deep reinforcement learning. These are all automation algorithms with minimal human interaction, and they are extremely important when there's an unknown future, because through pattern recognition, the computer can make predictions for the future. I have a flowchart here on what it would look like, the whole system of AI air traffic control. We start off when the flying car is given clearance to take off by the computer. Immediately, the distances are measured between each flying car and uploaded to an online system. After it is uploaded to the database, we use that information in order to make the computer smarter every single time. Depending on the situation, we may divide the area into sectors if there are different regulations or if there's lots of flying car density. Finally, we'll run it through the algorithm, and it would maximize the ideal value through a Markov decision process. And finally, this process will be repeated every single time, and it will make the computer smarter every single time as well. After the data is processed, it will be sent to the database to make a final prediction and sent to the user through the UI. Second, we have exterior airbags. One of the most important things for any car is the airbag. So what would it look like in a flying car? Collisions could cause many complications for anyone, and the best way to prevent collisions from being worse is to use exterior airbags to soften the damage and keep the car stable. The exterior airbag system is an excellent way to protect the passenger. One of the main problems also was falling objects. The exterior airbags would reduce the cause for falling debris significantly. So this also makes it so we don't even have to add any airbags on the roof of the car. The solution may have been easier had we been working with ground vehicles, but the fact that the car is flying makes this way more difficult. One of the examples of when this would be extremely useful is when a flying car is descending or preparing to land, because there may be surprise obstacles that may get in the way and you may crash into them. So the engineering behind it, sensor placement is extremely important here. We have to detect any incoming objects, and our goal is to deploy individual airbags rather than all of them at once. There will be 2 air compressors with embedded in the chassis, and those will be used whenever the airbags have to be deployed. Underside sensors will be crucial as well for the landing protection feature, and the airbags are also designed to wrap around the chassis to offer maximum protection. Here are some designs that I came up with on what it would look like. Just a very general looking vehicle here. These right here would be the air compressors. There's one in the back and one in the front. All of these are the airbags on the outside, and the amount of airbags may vary depending on the final design, but this seems to be the best design in my opinion. Here we have the sensor system, which is something we'll get into later on in the presentation. Here I have a front view of the front bumper, and the orange X's are where the airbags will be located. So if we go back, there will be 3 at the front, and these are the same 3. The pink arrows signify how it will wrap around the car for maximum protection.
So, driving and flying are two very different tasks, mostly because when flying, a pilot has to account for various aspects of the plane's positioning: wind speed, drag, thrust, fuel, etc., and they have to consistently be aware of the situation. Essentially, driving is a lot easier than flying. So, how will the body of the vehicle need to adapt to be airborne? Well, my first idea is to make sure that the chassis is made of an aluminium alloy. Aluminium, as well as other lightweight materials, allows for optimum protection for all passengers within the vehicle. My second idea is to equip the vehicle with an emergency parachute and life raft, which would be a last ditch option in case all else fails. So, the aluminium chassis. The specific characteristics of aluminium offers lightweight structures with high stiffness and energy absorption, making the safety of all passengers inside the vehicle the number one priority. As well as being cost-effective, the mass-specific energy absorption and capacity of aluminium is twice that of steel, and as well as the rigidity of aluminium is 50% higher than steel. Here's a photo of the aluminium chassis. Another one in the flying car. Okay, the built-in emergency parachute and life raft. As I said before, this is the last ditch option in case all electronics fail, and since this is to be used in when all electronics fail, or there's no electricity, or there's a blackout. This feature, the safety feature, is completely non-automated. It can be either activated automatically or deployed manually by the pilot or driver, whichever one they choose, to ensure the vehicle lands safely. This accounts for both land and water landings. Here's a picture of an example of a life raft, and here's another of a parachute.
So my goal for the aircraft is to be able for the person to control the aircraft, but as well as make it go on autopilot. So the final product should be able to have complete control with the AI that could avoid collisions and could navigate going back to the home point, keeping the person in the aircraft safe at all times. My idea so far for this is having GPS, so the aircraft knows where the surroundings are, like other aircrafts, birds, and if it's flying or taking off, such as like tall trees, being able to see completely without any lost connection or anything like that. The second idea is license registration. So it needs to be passed in order to fly the aircraft. You can't get in an aircraft without a license. That would just cause a whole lot of trouble for everyone. So a little bit more in depth about the AI. So in order for the aircraft to be completely controlled by AI, there needs to be a lot of sensors around the aircraft with specific encrypted coding. So the driver doesn't need to be completely in charge of the aircraft. He can be in charge, or he or she can be in charge of the aircraft, but it's more of a safety concern that it could be on autopilot at all times. Idea number 2 would be for the license. There would be way more stricter laws, and it would be a little bit more difficult to get this type of license, but it shouldn't be too hard. It would just take a lot more classes and a lot more tests, just so the driver could be a little bit more understanding of this is not a regular car or a toy. This is an actual aircraft that you could fly. So they need to be a little bit more understanding about that.